Hello my dear students, I am your maths faculty Arpita Sharma. Students, we are discussing class 10th mathematics and in that series we have reached to chapter area of circles, area related to circles, and we have done so many questions based on that and also the combination. We have completed a theory part and our most of the question types has been covered. So in this particular lecture we will be doing some very few questions and we'll rewind our chapter, right students, because it's the last chapter of this particular, last lecture of this particular chapter. Okay, so moving forward with the series of the questions, I'm having this question in this figure, a square OABC. Now square OABC is this, is inscribed in a quadrant. Now these words are important. It's inscribed, this is important, in a quadrant OPBQ, that is OPBQ. So that is quadrant of a circle and I'm having a circle inscribed in it. Now if OA equals to 20 centimeters, now OA is given what? 20 centimeters. Find the area of shaded region. Find the area of shaded region. So if you are not provided with the shaded region, let me give you shaded region here. This is your shaded region. This is your complete quadrant. This is the shaded area, right? So you have to calculate it. Now how can you calculate it? You will simply find out this quadrant's area and will minus this square area. Now square area is 20 by 20 because it's square, so it will be by 20 by 20. Okay, sorry. Now the second thing is, how will you find the quadrant area, because you are not provided with the radius, because the quadrant area is equals to what? 1 by 4 multiplied by pi r square. So we are having pi, we are having this 4 and we are not having this r. Now what is this r? If it is inscribed, it is this particular line CB touches at this circumference. So if I meet B to this point O, then OB will be nothing but the radius. Now this is 20 and this is 20. So what will it be? Obviously the square root of summation of these two, the square root of squares of these two side summations, right? So I will be doing the same thing here students. So look carefully, right? The solution part. For this question I am having the solution part. Here area of shaded region, area of shaded region, or you what call region, right, equals to what? Area of quadrant minus area of square. Now what I'll tell you that now area of quadrant, or I'll just first will be having this area of square equals to side square, side equals to 20, which is centimeter, and it's given. Now and area of quadrant equals to what students? It is nothing but 1 by 4 pi r square, so it will be 1 by 4 pi r square. Now this radius is not given, so I will be talking about this radius. Here in triangle, this triangle OAB by which theorem? Pythagoras theorem. by Pythagoras theorem, we are having what? This OB square equals to O square plus AB square. That will give me OB equals to, if I am directly writing the values, 20 square plus 20 square whole root. Now it is what? It is 20 square is what? 400 plus 400 will be equals to what? 800. Now 800 is what, students? That will be 2 multiplied by 2 multiplied by 2, this is 8, and 10 multiplied by 10, this is 100. Okay. Now that will be 2 from here, 10 from here, that will be 20 by 20 multiplied by root 2 in centimeters obviously. Okay. Now what I have to do, I have known with this radius and I have known with this side, so I can just put the value in equation 1. Right. So putting the values, in equation 1, what I am having is nothing but area of shaded region equals to 20 multiplied by 20, okay, minus 1 by 4 pi r square. 1 by 4 pi is 22 by 7. No, it's asking us to have pi equals to 3.14. Okay, pi r square. Now r is 20 root 2. So multiply by 20 root 2. Multiply by 20 root 2. Now students, this 4 can be cut. Can cut this 20 by 5 times. Okay. Now when I will calculate this, that will be what? 2 2s are 4 and 2 zeros here. Right. So 400 minus this 3.14 multiply by 5 multiply by 2 is 10. So this is 100. Root 2 multiply by root 2 is 2. So I have covered this 3.14, I have covered this 5 and this 20 here and this 2 here. Okay, so completed it. Now that will be equals to 400 minus, can I just do the process or can directly write it is 314 multiplied by 2. What will it become? What will it become, students? It will become something more. So I have done something wrong here. Area of quadrant. Okay, so we have just done one thing. We have written this area of square in the first place and then minus this. Okay, so I can just reverse this. This will be here and this will be here. Right, because the area cannot be minus obviously. So that will be area of quadrant, that will be 1 by 4 pi 3.14 r square, which is 20 root 2 multiplied by 20 root 2. Okay, and then in minus I will be having this 20, yes, 20 multiplied by 20. Right. So here I will be having this 4 cut by this 5 times again, 3.14 multiply by this 5 and this, that will be 100 multiplied by 2. Okay, minus 2 is 4, 100, that will be 314 by 2 minus 400. Now what will it be? 8, 2, 6 minus 400. Will it give you nothing but 228 centimeters square. So the area of this shaded portion will be what, equals to what? 228 centimeter square. and this particular is what your answer, my dear students. Okay, in centimeter square. So note this, students, so that we can move forward to next question. Right. Okay. Right, students. So in the next question, I'll be having this design area. Now we'll be confused that ma'am, we haven't read about this particular area. How we're gonna find that particular thing? This is simple. We just have to percept things. Okay. Now calculate the area of the designed region. Designed region is this. This is a complete region. Don't mistake it by this. This is having a blank space. No, you have to calculate it complete here, here, right. This complete portion you have to calculate. Right, students. Now you're having this square. This square having side of 8 centimeter. So you have to calculate the area of the designed region in figure common between the two quadrants of circle of radius 8 centimeter each. Now it's having given you hint, but what if it's not giving you hint? It's giving you hint in this common between the two quadrants. Okay, this is your hint. How? I'm telling you to find this area. Now can I divide this area in two halves? Be specific. In two half, this and this area 1 and this area 2. Now how can you calculate this area 1? You're having this complete quadrant area circle. Now what will you do? For this particular second area, I'm telling you. Now you will minus this triangle's area. You can find out the triangle's area with the given sides. Okay, so you'll be having this complete quadrant's area. You will minus this area, this side area. So what will you having? You'll be finding out this complete area. So this area is found out. Now for this area, what will you do? You will consider this quadrant. This quadrant you have considered. Now considering this quadrant, you will minus this area, this triangle area. If you minus this quadrant and this triangle area, what will be remaining with this area? So if you add this area and this area, then you will be having this particular side area. Now students, the sides are equal. Okay, this is symmetrical to this axis. So if I find out this area and will multiply it by 2, I can find the both areas simultaneously. Okay, so I am using the same concept here in my solution, and I am writing that area of shaded portion. Area of what? Shaded portion equals to what, students? 2 multiplied by double. Okay, 2 multiplied by, if I put a point here, this is A, B, C, D, and let's suppose it's E. So can I say area of quadrant either, and I will name it like F. Either I will talking about A, B, E, D, or I can use both, or C, B, F, D. C, B, F, D. Okay, so quadrant area of this equals to quadrant area of this. Okay, now minus area of triangle. Area of triangle. Which triangle again? I can have ABD, or I can have this BCD. It's not compulsory for you guys to write it like this. You can just write this like 2 into area of quadrant minus area of triangle. Now mention the area of quadrant ABED, anyone from them. If you are using ABED, then use ABD, and if you are using BCF, then use BCD. Okay, so if I will put the values here, area quadrant equals to 1 by 4 pi square, and area triangle equals to 1 by 2 base into height. So I am just putting the values in equation, implies that area of shaded portion equals to this complete area 1 by 4 pi r square. Now r is what? R is 8 multiplied by 8 minus 1 by 2 base. Now base of this triangle, if I am taking this triangle, base is 8 and height is what? 8, right? Is this so? Now what I can do, I can cut this 4 by this 2 times and this by 2 times again. Okay, so if I am taking common something here, that will be 16. If I am taking this 16 common here, what will you having? I have taken this 16 here and this 16 here common. Is it so? Okay, am I mistaken something? That will be cut by 4, right, and that will be by 2. So I can do 16 common, so there will be, I will be lefting with 22 by 7, and here 2 and I am taking this. Okay, so here I am be having this 2, that will be 16 multiplied by this 7, that will be 22 and that will be 14. So what it will be? 17 multiplied by, that will be 8 by 7. Okay, so I can write it as 128 by 7. So this will be what? In centimeter square will be the answer of the shaded portion. So this shaded portion will be the area of 128 centimeter square. Right, students? Note this. Okay. So students, this is what we have covered. All types of varieties in our questions. We have done a lot of questions on this area and the combination particularly. Now it's time to have a quick revision of the chapter. Okay students, so we'll have this quick revision. Okay students, so we just started from here, that is the name of our chapter, which is areas related to circle. In this particular chapter, we have gone through the definition of circle, that a circle is what? A locus of a point which moves in a plane in such a way that its distance from a fixed point always remains constant. Then we said that this fixed point is called radius, and this fixed constant distance from that point is known as radius. Okay, so for your reference, that was our center and that distance was our radius. Okay students, now the perimeter of this circle, this complete perimeter was known as circumference, and then we have the formulas for perimeter and the area of the circle. Circumference, we found out that circumference formula is 2 pi r, and if you substitute this 2r equals to d, then that will be pi d. So, circumference formula is 2 pi r or pi d. Here we find out that the area in terms of r, we generally use the term r, not the d. Okay. So, in terms of r, that means radius is equals to pi r square, but if you consider this as d, so that will be pi d square by 4. How? We just substitute r equals to d by 2. Okay. Now, area of semicircle is nothing but you will just half the circle's area, complete circle's area, which is pi r square, so it will become pi r square by 2. Then we call the area of quadrant of a circle. Quadrant area is that means we are having 1/4 of the circle. So, area will be also 1/4. So, area of quadrant of circle is nothing but area of circle divided by 4, that is pi r square by 4. Sorry, pi r square by 4, right. Okay. Now, then area enclosed by two concentric circle. We understood that this circle, complete circle, let's call it C1 and let's call it C2, having the radius r for this C2 circle and small r for C1 circle. Then we have find out if these two circles are concentric and enclosing some areas in between these two circles, then the formula for this will be equals to what? Pi r square equals to what? Pi r, capital R minus small r, squares of that. Pi capital R square minus small r square, like that. And we have just substituted in that manner that we in the questions we will be using this format, so then the calculation can be easy. That will be the formula pi r plus r, r minus r. Okay students, then we have some useful results. What? That if two circles touch internally, then the distance between their circles, if two circles touch internally, then this will be the radius r1 and this will be the radius r2. So, distance between their centers will be the difference of their radii. Okay. So, if two circles touch internally, then the distance between their centers is equal to the difference of their radii. This was our first result. And if it happens like this, that this circle is touching this circle, so this will be r and this will be r. So, that will be what? The distance, the distance from center to center will become the summation of radius. So, we have just to justify it here that if two circles touch externally, then the distance between their centers is equal to the sum of their radii. Okay. Now, distance moved by a rotating wheel. If a wheel moves, okay, so one circumference if it covers, then that will be 2 pi r. Okay students, so we have just specified this thing here. Distance moved by rotating field in one revolution is equals to the circumference of the circle of the wheel. The number of revolutions, we have used this in our CAST question, so I am just reminding it to you. The number of revolutions completed by a rotating wheel in 1 minute is nothing but the distance moved in 1 minute divided by the circumference. Okay students, then next we have done these questions on these particular things. Then we find out the sector. I have told you about the pizza and the sector. Okay, then this sector's area will be what? Pi r square theta by 360. Okay, so we are having these two minor sectors. The minor sector is this one, okay, angle theta, and we were having this major sector. Major sector is this complete area. This area is minor sector and this area is major sector. That was something like that only. And we have that we have concluded these important points to remember that the minor sector has angle theta, okay, and major sector is having no angle. We can write that 360 minus theta is the angle. Okay students, now sum of arcs of major and minor sectors of this circle equals to circumference of circle. How? This is minor circle's arc, this is major circle's arc. So these two arcs will be making the complete circumference of circle. Now the boundary of a sector consists of an arc. Now if it is the sector, then boundary we'll be having what? This arc plus these two radii. Okay, students. Area of sector, I've told you that the area of sector is nothing but, where's the area? Here, pi square theta by 360 and length of the arc. Length of this arc equals to pi by 180 multiplied by pi r, and we denote it by small l, that the length of r. Okay, students. Then we can also tell it that theta by 360 multiplied the area of the circle is nothing but what? The area of sector. Useful results for if angle subscribed by minute hand. We have used that that watch, right? And we have told that if you are having angle described by minute hand 60 minutes, that equals to 360 degree, and angle described by minute hand in 1 minute equals to 360 by 60, that will be 6. Okay. Minute hand notice to an angle of 6 degree in 1 minute. Okay. Useful results, again we are having some questions. And segment of a circle, the segment of circle is what? If you are having 2 points and if you are having this chord here AB, then this particular area will be known as what? What? Minor segment, and the other one will be called as major segment. Okay, students. So minor segment is here and major segment is here. So in this particular, this will be the minor and that complete will be major. We have find out the area will be equals to what? The area of this will be equals to pi theta by 360 minus sin theta by 2 cos theta by 2 multiplied by r square. We derived this relation also. Okay, students. Then we have some questions and we then take the complete look of variety of questions, right, students? So this was all about today's lecture and this complete chapter that we have studied in these particular lectures. Okay, students. So we'll meet in our next lecture with a brand new chapter. Okay, students. Till then, take care. Thank you.